Good morning, everyone, and welcome to SIICaP Lakbay, Kalawakan. Thank you for celebrating the Philippine Space Week with us today. I am Nico Pante from the High Performance Computing and Information Systems Division, and I am one of your hosts for today.
Hello, good morning, everyone. I am Matthew Medrano of the Space Mission Control and Operations Division of the agency, and I will also be joining Nico as one of your hosts. So let's get into it. Today, we will be diving, or might I say launching, into the world of rockets. And we are very excited to introduce to you our esteemed speakers who will be guiding us through what goes on behind the scenes of rocket launches, from how missions are designed to how launches are executed, and the careful planning and preparation that goes on behind every successful launch. So our first speakers for today are from a private rocket development company in Korea that is on the way to launching orbital and suborbital rockets for various commercial applications. So very exciting. And after this, we will learn from one of our nation's very own pioneers in the field of rocketry and their journey into launching the Philippines' first hybrid rocket. And this ties very well with our theme for the Philippine Space Week, which is hashtag Yamang Kalawakan, tungo sa maunlad na kinabukasan, which translates to space resources for a better tomorrow. So how timely is that? So back to you, Nico.
Thank you, Matt, for the brief introduction to today's webinar. So we would like to acknowledge our participants from various sectors. So from the local government units, national government agencies, colleges, and universities. And just a few reminders for our audience. Please stay on mute. And if you have any questions, please do not hesitate to drop them in the chat box. And rest assured, we will present them on your behalf during the Q&A session. Second, the session is being recorded and can be replayed in our YouTube channel. And finally, please accomplish our evaluation form to receive your certificates.
And now to officially start the program, Secretary of Finance Benjamin Jokno, who is also a member of the Philippine Space Council, joins the celebration of the first ever Philippine Space Week through a recorded message. Let us watch Secretary Jokno's message of support. Another one to give an opening message is Doc Israel Zinar Bautista. He's the officer in charge of the Space Mission Control and Operations Division, and he will give a message after this video. Right, so let's wait a while the video is being prepared of Secretary Jokno. Okay, so while the video is being prepared, let us have Sir Izzy, as we call him, or Doc Israel Bautista, for his opening remarks.
Hello. So good morning to all our viewers and those who joined us in our SIICaP Lakbay Kalawakan series. As we continue to celebrate the Philippine Space Week, and before I give my opening remarks, I would like to share the message from Secretary Renato Solidum Jr. of the Department of Science and Technology, who also stands as the Vice Chairperson of the Philippine Space Council. So let's watch this video.
Excellencies, distinguished participants, ladies and gentlemen, a pleasant day to all of you. I, together with everyone at the Department of Science and Technology, am honored and delighted to extend my continued support to the Philippine Space Agency as we come together to celebrate the Philippine Space Week. Today, we gather to honor an event that has captivated humanity's imagination for generations, the exploration of outer space. Since we started our Space Science and Technology mission in DOST, the World Space Week has marked a moment of pride for our nation, as we acknowledge our remarkable progress and accomplishments in space science and technology. And it is with great pride and honor that I say it is through the collective efforts of our brilliant scientists, dedicated researchers, and innovative engineers that we have achieved significant milestones that have placed the Philippines on the map of space exploration. Recently, August 8 to 14 of every year has been officially declared as the Philippine Space Week to boost space awareness among Filipinos. The proclamation recognizes the impact of space science and technology applications to the socio-economic development of the country. Hence, the Department of Science and Technology is one with the Philippine Space Council in recognizing the significance of space science and technology in addressing various challenges in our society and communities. I know you will agree with me when I say that space infrastructure is a key component of Yamang Kalawakan. This is why, with the support and collaboration of various stakeholders from the government, academe, civil society, and the private sector, the Philippines is now well equipped to harness the vast opportunities, resources, and infrastructure offered by space science and technology. As other nations continue to invest in space research and exploration, we also continue to do so by supporting the Philippine Space Agency's endeavors on space exploration. The DOST continues to invest in research and development initiatives that harness space science and technology for the benefit of our nation. These includes projects aimed at improving weather forecasting, disaster risk reduction, agricultural productivity, and environmental conservation. Through the Advanced Science and Technology Institute, or DOST-ASTI, and the Philippine Institute of Volcanology and Seismology, or DOST-PHIVOLCS, we have been implementing activities as well as further research for ground motion monitoring, flood detection, and flood extent mapping. We have been utilizing various space datasets and assets for land cover mapping, aquaculture monitoring, and even forest and watershed management monitoring around the Philippines. We continuously work hand in hand with our partners and stakeholders, especially with the Philippine Space Agency, to establish and strengthen the policy environment for effective disaster risk management and build the capacity of national, provincial, and local disaster management institutions through capacity building activities and technology proliferation efforts using Earth observation data. But the significance of satellites does not stop here. The Philippine Space Week is a time to reflect on our accomplishments, inspire future generations, and reiterate the importance of space science and technology in shaping our world. What the Philippines have so far are indispensable tools in driving socioeconomic development in our country. From revolutionizing communication and navigation to enhancing disaster preparedness and environmental monitoring, space technology has been vital in addressing the pressing needs of our society. As we celebrate our accomplishments with PhilSA, we also look towards the future with great anticipation and excitement. Our commitment to space science and technology is unwavering, and may we all continue to support PhilSA's endeavors to explore new frontiers, advance research and development, and foster international collaboration. Together, let us embrace the possibilities that space science and technology offer. As we delve further into the cosmic frontier, let us never lose sight of the profound impact our efforts can have on our world and the lives of Filipino people. DOST is one with you in all your endeavors. Maraming salamat at magandang agham po sa inyong lahat.
So that was again Department of Science and Technology Vice Secretary Renato Solidum Jr. As Secretary Solidum mentioned, humans have always been captivated by space exploration. I remember more than 20 years ago, I was reading this children's encyclopedia about astronauts, rockets, and moonwalks, where I was also captivated by the dream that someday, perhaps, I could be one of those people who rides these huge rockets and reach for the stars and distant planets. Now that we have our own space agency, I think we are one step closer in making this aspiration of Filipinos who have a similar dream as mine into reality. The Department of Science and Technology paved the way for Filipinos to reach for the heavens above by initiating the first satellite programs in the Philippines, which gave us our Diwata satellites and Maya satellites. One of our speakers today has also benefited from the support of the Department of Science and Technology through their Young Innovators program. As the Philippine Space Agency takes on the mantle of leading our country in space science, technology, and applications, we believe that the value of space, or hashtag Yamang Kalawakan, will be harnessed when we have a critical mass of scientists, engineers, and citizens working towards the utilization of space for the common good. As such, we have these webinars to inform, interact, and inspire Filipinos on these technologies. Our webinar today discusses the ways humans have been doing to explore the vastness of outer space, which is through rockets. Launching and operating these rockets is truly a fascinating achievement of human civilization, as it involves the application of physics, mathematics, chemistry, engineering, and other disciplines to have a vehicle that can escape Earth's gravity and reach the outer space. A lot of these technologies that we use now is made possible by the successful launch of rockets into space. And it is always a big event whenever rockets are being launched to space, as we hope for all systems to work as designed. One small error could mean losing millions worth of space vehicle and the payloads it carries, and sometimes lives of astronauts that these rockets carry. Truly an engineering marvel rockets are. And in this webinar, we hope you would learn more about these rockets and the efforts of our country towards this endeavor. We hope for your active participation later as you send questions to our speakers. Magandang araw sa ating lahat and thank you po.
Thank you very much, Dr. Israel, for that opening message. And for now, let us watch Secretary Jokno's message of support.
The Department of Finance joins the Philippine Space Agency in the inaugural celebration of Philippine Space Week with the theme, Yamang Kalawakan tungo sa maunlad na kinabukasan. As the country's primary agency for advancing space science and technology, the Philippine Space Agency stands at the forefront of our nation's journey towards an innovation-driven, climate resilient, and globally competitive economy. Your work with space technologies and satellite data have contributed immensely to the work of many other government agencies in areas such as agriculture, national security, and the environment. The successful launching of our locally developed CUBE satellites, namely Maya 5 and Maya 6, to the International Space Station demonstrates the Philippines' determination to become a key player in the ASEAN and global space community. Moreover, your partnership with the Korea International Cooperation Agency to strengthen our capacity to monitor air quality conditions and enhance air quality plans and policies highlight the importance of space science and technology applications in the socio-economic development of the Philippines. Now I call on our partners from the private sector, the academe, the scientific community, especially our Filipino scientists, innovators, and trailblazers from all over the world to join us in this journey and help us realize our vision of a prosperous and progressive Philippines. Thank you very much and happy Philippine Space Week.
All right. Thank you, Doc IC, for your welcome remarks. I am sure everyone is as curious as to how rockets are launched. And thank you to Secretary Solidum and Secretary Jokno for your warm messages and celebrating the Philippine Space Week with us. And to really officially start our presentations, our first presenter for today is Ms. Diana Quan. She will be introducing us to Perigee Aerospace. Diana is currently the current country head of Perigee Aerospace for the Philippines. She completed her education in the country, the Philippines. Diana has used her vast local networks and passion for business development to create a bridge between Korea and the Philippines for the upcoming projects of Perigee. So, good morning, Ms. Diana. Thank you for joining us. You may now start.
Good morning, everyone. I'm Diana Quan from Perigee Aerospace. And first of all, I would like to thank Philippine Space Agency for having us here today for this exciting new webinar. And we would also like to thank Congressman Paul Daza, representative of the 1st District of Northern Samar, and Senior Deputy Minority Leader of the House for taking the time today to join us here today. I don't want to take up too much of your time as the main event will be presented by our founder and CEO, Mr. Dong Yun Shin, who will be sharing some insight into our exciting new technologies that are currently on the way. I'll just pull up one presentation for the intro. So Perigee Aerospace, we're a South Korean licensed spacecraft manufacturing company. And what is it that Perigee actually does? Well, first of all, to have access to space and the data that comes with this access, there are three fundamental things that are needed: a ground-based operations center, a missions operations center, and I guess most importantly, a spacecraft with hardware on orbit and software to power it. A rocket or a launch vehicle that provides both affordable and accurate path to orbit. And at Perigee, both the software and hardware of its launch vehicles are internally developed. And Perigee is currently developing a two-stage launch vehicle with a length of 20.6 meters, which can carry a 150 kilogram satellite into sun-synchronous orbit. The Blue Whale rocket is currently undergoing its developmental stages in Korea. You can see the size of the rocket at the very left of this slide as comparison. So it's a small projectile with a big dream. And the reason why it was called the Blue Whale is because the name of the vehicle is coined with an imagery of a dream of a whale going through the universe, which is a new sea for us to be explored. And the earlier prototypes of Blue Whale has previously conducted 3 trial launches in Jeju Island in South Korea from December 2021 to March of 2022. And with these new generation of rockets, Perigee believes in making commercial launches for the satellite market more affordable and accessible to customers looking to launch more frequently at a cost-efficient rate, and to untangle the complexities of costly launches for companies, researchers, governments, and students alike. We want to launch innovational space ideas into orbit more frequently in the near future. And Perigee is currently in the process of preparing for the setup of its Philippines branch office as we aim to conduct our symbolic trial launch in the country next year. The Philippines is an optimal place for such launches due to geographical location, being near the equator and surrounded by large masses of water. In line with this, we've partnered up with the Philippine Space Agency for collaborative work and research for processes that may be necessary for commercial launches in the Philippines in the near future. And launching a rocket, it's really no easy job, but the esteemed group of engineers at Perigee, headed by Mr. Shin, have come up with operations and procedures to make it possible. Now we'll hear from Mr. Shin on what his team has prepared so far. Thank you.
Thank you very much, Ms. Diana, for introducing Perigee and its mission. And I'm sure everyone here in the audience is very excited to hear exactly how these rockets are going to be launched. And so now we move on to the next presentation. Together with Ms. Diana is Mr. Dong Yun Shin. He is the founder and CEO of Perigee Aerospace, and he is here to talk about orbital and suborbital rocket launch vehicles. Mr. Shin studied aerospace engineering at the Korea Advanced Institute of Science and Technology. And fueled by his passion for rocket science, Mr. Shin has created Perigee Aerospace in 2018 to bring private rocket launching around the globe in a both accessible and affordable manner for many. So thank you very much, Mr. Shin, for joining us today. So the floor is yours.
Okay, well, hello everyone. Good morning. I'm sure you can see my screen. My name is Yun Shin. I'm the founder and the CEO of Perigee Aerospace. So Perigee specializes in developing liquid rockets. So we started off as a development team for liquid rocket engines. So we build 1-ton class liquid oxygen, liquid methane rocket engines 4 years ago, and we scaled up that rocket engine and then flew the vehicle based on that engine several times. And now we scaled up the engine up to 3 tons, and we are now preparing for the first private orbital launch in South Korea next year. So I'm very excited to share our plans and current status of our company. So today I'm going to talk about the Blue Whale 1, which is our first orbital launch vehicle, its development status and flight plans. So I'm sure many of you know that the small satellites are really paving their way. Last year they launched a lot of satellite manufacturers. They launched about 300 satellites, small satellites into orbit, and that number is growing further and further. And recently I saw this news about rocket launches. Although SpaceX is launching a lot of launch vehicles, last year I believe it was about 50 rocket launches, and this year it's already 40 something number, and it's growing. But still, there's a lot of launch vehicle shortage because there's a lot of satellites wanting to go to orbit, and there's simply not enough launch vehicles to support that. So we believe there's still some demand for the launches of these small launch vehicles. So this is why we started our journey. So currently we have about 5 branches in South Korea. This is a map of South Korea. So we have our headquarters in a city called Daejeon. So this is where I'm currently at. And about 30 minutes drive, we have a production facility for rocket engines and launch vehicle propellant tanks and avionics. So we build basically all major hardware in-house. So we have a production facility nearby the headquarters. And we also do some defense manufacturing for Korean defense contractors. So we have our production facility for some of the defense products like airborne missiles, ground-to-air missiles. So we share basically the same technologies. So we have this defense branch for our basically some profitable projects while we are developing the orbital launch vehicle. And we have our technology research center in Seoul. So this is where some of the software R&D and avionics R&D are happening. And we have our launch site in Jeju Island because we have a very small corridor in between China and Japan. Our future goal is basically to build a private launch site in Philippines and conduct some of the equatorial launches in the Philippines launch site. So this is some of the brief overviews of our facilities that we have in Korea. So our main engine is rated at 3-ton thrust at sea level, uses liquid oxygen and liquid methane. So we have a small 3-ton class single engine test site in Daejeon. So this is how the engine is being fired. So we built this site in 2018, shortly after our initial foundation, and we tested over 1,000 firings up to now. So this is a very busy site, I would say, because most of the development of the rocket engine, they end up at hot firing, and we generally discover a lot of issues with new designs, with some injector design has been changed, then we have some issues to fix. So generally, what we do is to simply do the static fire, identify the issue and change it, and test it over again. So so this is what that kind of activities are happening. And we have our rocket development complex in Okcheon. So this is our manufacturing site. So we manufacture our carbon composite tank, our rocket engine, and our avionics in-house. So we need to have those facilities and for example, like clean rooms for assembling the avionics bay, and engine manufacturing. It needs a lot of toolings, lathe, mills. So we have those equipments here. And then we have some defense manufacturings on like this. And we also launch our rockets in Korea, currently in Jeju Island. So our ultimate goal is to provide all satellite manufacturers the sustainable access to Earth orbit, and someday beyond our orbit. So that is our mission. And the vehicle that we are developing right now is a 2-stage launch vehicle. So it has a total length of 21 meters and with a diameter of 1.6 meters. And the takeoff mass is roughly about 19,800 kilos, or slightly less than 20 tons. So our target price is around $18,000 per kilogram. I'm sure that is probably the most affordable launch for a small satellite, including ESPA class payload adapter rings, and all the additional services that normally other launch vehicle companies charge like separately is included in our launch service. So this is combined with all those services, it is going to be the most affordable launch vehicle for small satellites. So we are trying to achieve this price based on lightweight structure technology based on carbon composites and our methane engine, because methane, the propellant is actually cheaper in Korea to use than kerosene. So we can reduce the running cost, and furthermore, it is more efficient and it's better for reusability. And the vehicle is a 2-stage design, and we designed the vehicle so that the second stage is fully enclosed inside the fairing, which is attached to the first stage. So that normally what launch vehicles do is that the first stage returns to Earth using propulsive landing, and the fairing is captured separately. But by doing so, we need to have separate vessels for recovering those fairings. So we decided to include a fairing to the first stage, so that we don't have to have a separate effort to recover the fairing. So so that's why we have our second stage inside the first stage. This is the performance. So currently we have 2 candidate launch sites. So the first launch site is Jeju, which is in Korea, and the other launch site that we actually begun our construction, and that second launch site is S-Range, which is in Sweden. So S-Range is home to European sounding rockets for over 60 years. So we signed a contract with Swedish Space Corporation to refurbish the launch site and transform it into a orbital launch site. So by doing so, we can have more launch capability for sun-synchronous orbit launches, as you can see in this diagram. So so our basic plan is to operate in Europe to attract the European customers. So since our first vehicle is our first stage is it's very lightweight. The downside of having a lightweight structure is that by the time the propellant is fully depleted, the G loading on the payload can be excessively high. So what we do is we throttle down the first stage at T plus 160, 170 seconds, shortly after full main engine cutoff, so to maintain the G level less than 7G. And then our second stage ignites, and it goes all the way to orbit. So the second stage fires for 400 seconds, and it has a lower acceleration because the first stage already provided the acceleration all the way up to, all the way up to 500 kilometer. What the second stage does is it accelerates mostly horizontally to gain the orbital speed. So this is the mission profile, and the payload is the payload capacity is, I would say, up to 220 kilograms. That is when the vehicle is fully expanded, and the altitude, and it's gonna be 300 kilometer sun-synchronous orbit. So that's when the vehicle can achieve about 220 kilograms into orbit. And when it's fully reused and reused and launched in Jeju, the payload capacity is around 150 kilograms. So we frequently we like to talk about the technologies behind this vehicle. So I would say there are three main pillars for making this launch vehicle into reality. So the first thing I would pick is the avionics. So it's actually very tricky to reduce the size of the avionics while maintaining the same functionality. And in large launch vehicles, avionics, they don't take off like huge mass percentage wise. But if you make this vehicle smaller, then the amount of hardware that goes into avionics, they don't shrink in size with respect to the size of the vehicle. So that is the most tricky thing about this avionics. So yeah, that is the first pillar, and the second one is going to be the structure for this vehicle, because all the hardware like avionics, all the actuators, they don't get smaller. They don't get as small as the size of the vehicle. So somewhere you need to compensate for the mass. So I would say like carbon composite technology for that has LOX compatibility is quite essential to small launch vehicles. So if you make launch vehicles out of aluminum or some other metals in this small scale launch vehicle, you won't get any meaningful mass into orbit. So from the foundation, we focused on LOX compatible carbon composite tank, and I'll show you later on this presentation. And our last key is the small methane engine with a turbopump cycle. So I'll talk about it later. So the avionics, well, the approach is it's simple and straightforward. So we try to build everything, every avionics package, including the power management unit, flight computer, telemetry, or some hardware controllers, and like batteries. We build everything in-house using commercially off-the-shelf hardware. And the downside of using commercially off-the-shelf COTS hardware is that it is not as reliable as mil grade or military grade or aerospace grade hardware. So what we do is first we select some designs like multi-redundant designs for fault tolerance, and we test all the hardware basically rigorously based on some of the standards like mil standard 810 for testing individual components and the entire avionics bay. So the end product is that the complete avionics package costs less than $100,000, and the mass under 17 kilograms. So I think this is what enables our second stage and the first stage to carry a significant amount of payload while having the lightweight, and also it is reusable because of this lightweight hardware. And the second thing is the LOX compatible CFRP tank. we developed our resin system for LOX compatibility. So normal resins like just epoxies, they catch fire in a liquid oxygen environment when exposed to shocks. So we had to build this shock and flame resistant resin system, and the approach is that to make it sufficiently ductile at cryogenic temperature. So using these resin system and carbon fibers, we then developed our in-house winding and adhesive process. So you can see the picture on the center, and then the fully assembled tank undergoes a cryogenic testing before final assembly with engine and avionics. So we have our cryogenic test facility for our main stage and the upper stage tanks. So for example, the upper stage, our upper stage is pressure fed, and the main stage is turbopump fed. So the reason behind that is that the upper stage is going to be the stage that you basically throw out after emission. So we don't want to make the upper stage too complicated. So and make the recurring cost as low as possible. So the upper stage is pressure fed, and the problem with the pressure fed stage is that the tank pressure is basically higher than the pressure inside the combustion chamber. In our case, the main combustion chamber for the upper stage is 15 bar, and the tank pressure is around 20 bar. Because of the injector pressure drops in the valves and lines. So the 20 bar is the expected maximum pressure for our upper stage tank. And the problem is that all materials basically that can potentially catch fire, they can likely catch fire better in higher pressure. So we had to build this material to hold like even higher stress than other launch vehicles with carbon composites. So yes, so the tank is designed to hold about 500 kilograms of LOX and LNG for the upper stage, and it has to hold the pressure of 20 bar, but it weighs only about 30 kilograms. So this is probably the lightest upper stage because we don't have any turbopump. And downside of the turbopump is that it's very heavy when the stage is small. So turbopumps have a high advantage for large stages, but for stages like in this size, turbopumps are actually heavier than the structure itself. So by using carbon composites, we make our upper stage have a better mass ratio even better than conventional metal-based upper stages with turbopump engines. So the mass ratio, what I mean by mass ratio is that the mass of the empty stage versus the mass of the fully fueled stage. Normally, the upper stages would have about 8 to 10%. In our case, it's 9%. So it's actually better than turbopump fed upper stages you can see out there. And the final technology that I would like to mention is the methane rocket engine. It's not pure methane. We use liquefied natural gas. So we use LOX LNG combination for both stages for higher efficiency and reusability. And we design and build all of our rocket engine components in-house. And the turbopump technology, there's one exception, which is the turbopump technology, which is transferred from Korea Aerospace Research Institute. This turbopump that we use is based on a 7-ton class gas generator cycle engine that flew on KSLV-2, which is our second generation domestically built national launch vehicle. Our turbopump is based on Kari's technology because we started off by building our own turbopump, and later it didn't really take much time to realize that this turbopump is something that we cannot build from scratch. So our turbopump technology is based on Kari's technology, and we scaled down to 3-ton class so that by making turbines and impellers smaller. So I would like to show you some of the photos of our development sites. So this is our composite manufacturing facility. So we build and test our composite tanks before, and this is the cryocompatibility test before going into final assembly. Some of the leak checks. And this is the hardware in the loop simulation of the avionics bay and our upper stage engine before going into final assembly. So we have our hardware in the loop simulation for testing all the GNC algorithm and the flight sequences, so that to find any errors basically in a real-like environment. And for manufacturing the combustion chambers, this is always the problem for propulsion engineers, especially when they're trying to use regenerative cooling. So our main stage is regeneratively cooled. Our upper stage is it's a pressure-fed engine, so it is ablatively cooled. So the main stage engine uses 96 cooling channels, and the problem always is how to cover up these cooling channels. So we use a special technique called electroforming. So electroforming is basically it's electroplating, but plating it at a higher thickness. So we mill the chamber, we mill the channel in the copper liner, and we cover up with conductive wax, and then plate it with nickel. So the outer shell is made of nickel. So this is the process. It sounds easy, but plating it at a higher thickness is always the problem. So because it has some internal stresses on the metal, depending on the plating temperature and the plating speed. So so we had to carefully tune for this size for the size of this chamber, and we manufacture the chamber at about 1 chamber at a week. So we're boosting up the production speed, but we find that this is the fastest and lowest cost method to produce the combustion chambers. And this is the injectors. So we use a pintle injector. So I'm sure many of you rocket fans are familiar with different injector types. So we use pintle injectors so that these tiny holes they impinge liquid oxygen in a radial direction, and this small gap impinges liquefied natural gas. In this case, it would be gas in axial direction. So this liquid oxygen and methane fan is generated like a cone shape and initiates the combustion. We have these tiny film cooling holes in the perimeter of the combustion chamber to cool the combustion chamber. So we have film cooling for both upper stage and main stage. The main stage has a slightly less film cooling mass flow rate because the main stage is region cooled, and the second stage is made of silica phenolics, so it's ablatively cooled. So we have to have some film barrier more than the main stage engine. So this is the firing for this is a battleship. I would say this is a battleship type chamber, because why we call it a battleship is because we don't machine the outer shell into the internal contour. So so this is when we first test fire the main stage engine. So we test the TBC gimbal actuators, because it's not really necessary for like testing gimbals while the engine is being fired theoretically, because there's no difference in the forces that you need to generate to achieve that gimbal rate. But the reason why we did this, because there are some actual in reality the gimbal force changes because all the plumbings, all the pipings, they go into cryogenic temperature, and it gets stiffer. So we tested the actuator performance when the engine when the engine is chilled down to cryogenic temperature, and all the plumbings are getting the stresses when they're being operated. So our target price is so we wanted to show you this because of the target prices are comparable to some of the commercial launch vehicles. So I'm sure you know SpaceX, Rocket Lab, Virgin Orbit, which is now defunct, and Astra. So compared to these companies, I think we are going to be the most profitable small satellite launch vehicle, while also being the most affordable launch vehicle, even if it's expendable. So Rocket Lab is trying to reuse their rocket, and so as we. But our current plan is to launch first and try the reusability testing after all the launches being successful. So even without the reusability, the Blue Whale is going to be the cheapest launch vehicle out there that the satellite manufacturers can use. And also, we are testing some of the reusability based on turbojet engines. So we build these test launch vehicles based on gas turbines and the same avionics for our main stage. So this is when we are testing the hovering of the vehicle. So you can see it's quite stable. Actually, the left one is video, and the center one is the photo. So it's not that stable in reality. So yeah, so the controlling a small vehicle is always the problem, because it has a smaller moment of inertia, and that means it has to be controlled with a higher control frequency. So a higher control frequency means that you need to have you basically need to gimbal your engine at a higher speed. And the problem is that if you make your vehicle smaller, your engine does not get smaller proportional to the size of the vehicle, because there are some these functional components. They don't get smaller as some not functioning hardware, like structures, your tanks, as they do. So it is always a problem. And the problem is that if your engine is heavier with respect to your vehicle, if you gimbal your engine, the reactant force, we call it TWD effect, tail wags the dog. So your engine basically shakes your vehicle. Controlling those effects at a higher frequency bandwidth is always the problem. So we are testing these technologies in Korea, so that we can reuse the vehicle in the future in a smaller scale. So bottom line is that it looks similar to Falcon 9. It's way harder than Falcon 9 to actually control this vehicle in a stable manner. You can see the engine gimbaling like this. Yes, and we launched our first flight in Jeju Island. So this is our prototype launch vehicle. So we had these fins for our first launches. So later we decided to remove the fin because the vehicle was overstable during flight. So we launched these rockets several times in Jeju Island to test our rocket engine, our flight guidance and control, our avionics, and to demonstrate that we can actually fly these liquid sounding rockets confidently. So this is one of the videos that we launched this rocket. So this is 1/10 scale in terms of the size, and it can generate about it generated about 1 ton of thrust. So and it went up to an altitude of 30 kilometers. So we launched this rocket about 3 times, and then we signed a contract with Jeju Island to build a commercial launch site in Jeju Island. So since this island is quite crowded, we are not going to launch on the land. We are going to launch it basically on the sea. So this is the ship that we are building. So we are trying the ocean launch. So this oceanic launch will happen later next year, and the ship is being built. So this is the ship that we are building, and you can see the size by comparing it to the human size, right there. And for these upcoming launches, we signed some contracts with our satellite customers. Our first satellite customer will be a biological company that is wanting to grow some cells in space. So this is their payloads, and we are signing the contracts with them. Yes. So I mentioned briefly about our current status, and now I'd like to finish my presentation by sharing you some plans on the Philippines. So so in order to launch rockets, of course we need some launch sites in the Philippines. So our current plan is to start construction by building the ground tracking stations and launch pads probably in 2024. So our first goal is to bring up this. We actually built the tracking station for. So this is going to be shipped to Philippines probably later next year. So we are carefully reviewing some of the candidates for where to place this ground tracking station. This tracking station will be used normally for rocket launches. So when we are launching rockets, this antenna will track the rocket, its trajectory, and download the telemetry data. But when it's not doing it, we are going to use it for our satellite customers. So the satellites, Korea has about 60 satellites in orbit, and sometimes they pass over Philippines airspace. I mean, not the air, but over the Philippine horizon. So so satellite customers, they want to have more connections with their satellites to download more data by taking more pictures. So so we are going to use this antenna for downloading satellite data daily. So there's this additional profit stream other than the rocket launches. And so the site construction will take about 3 years. That is our goal. And while we are doing it, we will start our orbital launches in Jeju Island. So what the other thing that we can do is we can dispatch some of the drone ships near the Philippine Ocean, and then we can try some orbital stage landings after the first stage launches, and some maintenance jobs in the Philippines, and then we can bring back the first stage to Jeju Island and then launch it again and catch the vehicle in the Philippine Ocean and then bring it back to Jeju Island. We do it over and over. So there's so while the launch site is being built, we can try catching this vehicle and refurbish it and send it to Jeju Island for reuses. And I think this is something we can do it together while the site is being prepared. And I'm also talking with Diana about joint development and exchange programs. So we have established our engine manufacturing and vehicle manufacturing sites in Korea. So a lot of rocket engineers in Philippines, a lot of satellite manufacturers in Philippines can come visit to our site and learn more about what we can do together. And maybe you can start some joint activities like building a satellite and building rockets and launch it in Philippines. My target date for the first launch in Philippines is around 2026 after the commencement of the launch site. So I'm really I have a huge hope for that. Yes. So we are a rocket development team that is doing a lot of research and development in South Korea, and I'm really happy to introduce our activities to a lot of engineers in Philippines today. I'm sure there's a lot of activities that we can do together, and I do have a high expectation about it. So thank you very much for listening to me. And if you have any questions, please ask or send us an email about your questions. Thank you very much.
All right. Thank you, Mr. Shin, for your presentation and accepting our invitation was very informative presentation showing the stages of the Blue Whale and the different technologies behind it. The highlight for me is the cost of launching the satellites. I think it's low-key highlighted the importance of developing small satellites like our lightweight Diwata 2, since the price goes higher depending on their weight. So let's go now to our first Q&A session. I'm sure our audience has questions for Miss Diana and Mr. Shin. So please, if you have questions in mic, drop it in the chat box.
All right, so we have a question from one of our listeners in YouTube, and it's from Nova Access. Would it be better to manufacture your own avionics than getting them commercially?
So sure, yeah. There's a lot of commercial options you can select for getting avionics. But the problem is the customization. So you have your own specific launch sequences and all the hardware. For example, like flight controllers, you need to have your own software basically. So to build a fully I would say fully customized software is to build your avionics. So so the cases become different when you are launching just a single rocket versus you're launching 1,000 rockets in the future. So if you want to build like 100 rockets and launch over and over, you certainly have to have your own manufacturing streamline because that is the only way to reduce the cost. So the recurring cost always matters, and commercial avionics you need to have I would say you need to pay for basically their profits. But when you're building your own avionics, sure you have to pay for development costs, but you can reduce the recurring cost. So yes, yeah. I'm not sure if I answered like correctly, but
Thank you for that, Mr. Shin. So another question from Teams. Will the maiden flight in 2024 be live streamed? And if so, do you have the link to the channel where the launch will be streamed?
Yeah. So we have our YouTube channel, but we are not really good at advertising, so we don't post any video. We don't post much videos there. But there's our YouTube. You can search Perigee and you'll see the link. Yeah. So we'll be streamlining our launches in 2024.
Okay, this next question is about our potential collaborations in the future. So this is from Joe Obras, and they're asking what are the ideal place that you are looking for in your Philippine testing site, and what will be the safety protocols and hazards for constructing rocket launch test center?
Well, I'm talking with my CFO and Diana about the launch site. So so I cannot tell you like the exact site that we are like considering right now, but we are looking for several sites as options. But the important criteria is first one is the downrange and the length of the downrange that we can obtain, and first and foremost thing is that the site has to be in the eastern seaboard of the Philippines, because so Jeju will be used for sun-synchronous orbit launches, and we'll work with Philippines for high altitude like low inclination launches, which means we are going due east, so we are launching eastward direction. So the next important thing is the downrange distance, because if you have some other countries in the downrange of the rocket while launching the rocket, the first stage can fall to some islands, and that can cause some troubles. So there's these two selection criteria. The safety protocol. Yes, we have like safety protocols, like we have to have 2 kilometers of range. That is not there shouldn't be any people in 2 kilometer radius. So that is another criteria. And then we have to have so we use mostly what we use is liquid oxygen and methane, and we use high pressure helium. So we have to have some safety management procedure for handling those gases, high pressure gases and explosives. But we don't use anything like hydrazine or any other like toxic fuels. So because Jeju is also very strict for environmental protection, so we don't use any